All right. So if you pull out the notes, it'll actually be 12.1, but in the modules, it's listed as 11.1. So you just want to change that 12.1 to 11.1 in chapter 11. All right. So if you pull out the notes, it'll actually be 12.1, but in the modules, it's listed as 11.1. So you just want to change that 12.1 to 11.1 in chapter 11. All right, so this is probability. So you do some probability in statistics, but here they're going to introduce probability to us. So let's see what it says. The nature of probability. What is the likelihood of something occurring? Can we answer questions about probabilities using data or experiments? For instance, if my parking meter expires, I will probably get a parking ticket. Say you want to find out how likely it is that a person will get a parking ticket within 30 minutes of the expiration of the parking meter. You ask all your friends to take the risk and let their parking meters expire, and then wait 30 minutes to see if a parking ticket is written. Of your 50 friends, 8 receive a parking ticket. The experimental probability of getting a parking ticket is, well, the denominator is always going to be the total number of people who participated. That's 50 people. And the probability of getting a parking ticket in this case was 8, because 8 people got it. So it would be 8 out of 50. There it is. So that's pretty much it that's called empirical probability, because you're using actual data or you're conducting an experiment. So it says the number 8/50ths is called the relative frequency probability or empirical probability. So that's what I was referring to as the empirical probability. It's the number of tickets received out of the total number of times the experiment was repeated. So, so the empirical probability is just going to be equal to the total number of times the experiment, the number of tickets received out of the total number of times the experiment was repeated. So let's see, I'll write that out. Number of tickets received out of number of times experiment was repeated. There was 8 tickets received out of a total number of 50 experiments. All right. Mr. Jones' grade distribution over the past 3 years for a course in statistics is shown in the chart below. What is the empirical probability of getting a C in the course? So we have to figure out the total number of students. That would be your denominator. Does anybody know? Well, yeah, we have to figure out how many total number of students there were in the class or in this 3-year time period. So if you guys want to add those up, let me know what you get. Everybody get 645?
5, yeah.
All right, so that's your denominator because that's the total number of students. And then of those total, how many of them received a C?
260.
Yeah, 260. So that's going to be the numerator, 260. And then we just have to simplify. It looks like we can simplify by 5. So let's simplify by 5. So divide by 5. Top and bottom. So 260 divided by 5 is 52, right?
Mm-hmm.
And 645 divided by 5 is 129. So the answer is going to be 52 out of 129. All right, so that is our final answer. So that's called empirical probability because we're using data, the data that's given to us to figure out what the probability is. All right, number 3, in an experiment, Mendel crossbred tall pea plants with short tea plants As a result, the second generation offspring were 787 tall plants and 277 short plants. Determine the empirical probability of a second generation plant being tall and short. So we start with getting the denominator, which would be the total number of plants. So if you add those two up, that will give you the total number of plants. So 787 plus 277, getting 1064. And the probability that it's tall would be, anybody know what the probability of it being tall would be?
787.
Yeah, that's right, 787, because that's how many tall plants there are. And then the short ones are obviously 277 out of
1064.
1064, right? All right.
Professor,
wanna
can
do-
you go back to example 2 and explain that to me one more time? So like in a test setting, you would be like, you simplify your answer, like you would make that like a thing.
Yeah, most likely we'll have you simplify it.
Okay.
And
Mr. Anales, why
yes,
did you divide it by 5?
oh, that was it? Or is this still the same thing? Let me double check real fast if this is what we're doing. Section 11.2 odds. All right, let me see, 11.2. Because this one says, is this still part of the same notes? Or is this the next notes? Oh, I see, yeah, okay, no, this is good. So ignore this, even though it says 12.2, just assume that's still part of 11.1.
Okay.
Just a continuation of what we're doing. All right, so now we're getting into a different type of probability. It's called theoretical or classical probability. So suppose each outcome has an equal chance of occurring, like flipping a coin, right? You can get heads or tails and you have an equal chance of getting both or either, I mean. So that's that would be an example of when you would use theoretical probability. We calculate the probability of a particular event, which is the collection of outcomes using classical probability. But first, let's make sure we understand the distinction between a probability experiment, outcomes, and events. So here's a table. So the experiment could be flipping a coin, or rolling a die, or drawing a card from a standard deck of cards without jokers. So these are called experiments. And then the sample space or the possible outcomes would be, you can either get heads or tails. Here you could get, anybody know what the outcomes are when you roll a die?
Oh, God, I
You
forgot.
get numbers
Yeah.
like 6, 5,
Oh, yeah.
10.
Well, there's only 6 numbers on a die, right? On the standard die.
Oh, okay, yeah.
So 1, 2, 3, 4, 5, or
5
6.
and 6.
Yeah, those are the outcomes. All right, possible outcomes. All right, what about drawing a card from a standard deck? Blank cards with a suit of diamond, hearts, clubs, spades. Total
13 cards. 13 cards
there's 13 with these. Let's
with
see.
each suit, and the total cards is 52.
Oh, that's
I like
right.
playing cards.
Okay, yeah, you're right. Because each suit has 13 cards, and if you multiply that by 4, because there's 4 suits, that gives you 52, right?
Okay.
Yeah, so that's true. Very good. All right. And then here's an example of an event. An event is one specific outcome. So maybe a heads, that would be an example of an event. Or rolling a 4, or a number less than 5, or an odd number, or choosing a club, choosing a 5, or a face card, or a red ace. These are all events. So that's just vocabulary. Experiments, sample space or possible outcomes, and then events. All right, so let's look at this first example. If the experiment is rolling a die with 6 faces, then the size of the sample space is 6, right? Because you can either get 1, 2, 3, 4, 5, or 6. So that's the size of the sample space. All right. Let's see what else. If the event E is rolling a 4, then the size of that event is 1 because there's only one way to roll a 4. Therefore, the classical probability of rolling a 4 is 1 out of 6. So the sample space is the denominator, and the numerator is the number of ways that you can get the event. The event is rolling a 4. There's only one way to get a 4, and there are 6 total possibilities, so it's 1 out of 6. So they do that one for us. There's one event, 6 possible outcomes, so the probability is 1/6. How many events are there for rolling a number that's less than 5?
Is it still one event? Because it's still one roll, right?
One.
It's one roll, but there's more than
So
one.
it would be 4, because it's 4 numbers less than 5.
Yeah, you're right. 1, 2, 3, 4. Those are the numbers. So that means there's 4 events, or possibly the number of events is 4. The total possible outcomes is still 6, right? Because we're still rolling a die that has 6 sides. And then so the probability of rolling a number that's less than 5 would be
4/6.
4/6. And we can simplify that by 2, right?
Right. 2/3.
So that would be 2/3. All right, so that's your final answer. All right, what about rolling an odd number? How many numbers are there? How many odd numbers are there from 1 through 6?
3.
3.
Yeah, 3 odd numbers, 1, 3, and 5.
Mm-hmm.
And the possible outcomes is still 6. And so your probability would be,
3 out of 6 or 1/2.
yeah, 3 out of 6, which is 1/2. All right, rolling a multiple of 3. Anybody know what the multiples of 3 are?
3 and 6, so 2.
Yeah, 3 and 6. So that means there's only 2 events. And there's 6 possible outcomes.
6.
So 2, 6, which is
1/3.
1/3. Yeah, that is right. Cool. All right. So let's see if it gets a little bit more challenging. A bag contains 6 red marbles, 3 blue marbles, and 7 green marbles. If a marble is randomly selected from the bag, what is the probability that it is blue? So let's look at the number.
3 out of 16.
Yeah, that is right, because there are how many blue marbles?
3.
3. There's
3.
3 blue marbles. So that's the number of events. What's the total number of possible outcomes?
16.
You have to add these up, right? Yeah, 7 plus 3 plus 6 is 16, right?
Mhm.
And so the probability is 3 out of 16. And that's as far as we can go.
Okay.
All right. California, a number from 1 to 11 is chosen at random. What is the probability of choosing an odd number? So, anybody know how many odd numbers there are between 1 and 11?
5 out of 11.
5.
I think you're right. Let's count them. 1, 2, 3, 4, 5. Oh, actually 6, right?
Oh, including 11.
Oh, 11. Okay.
I didn't include an 11.
Oh, okay.
yeah, including.
Because it
So
didn't say under 11. It said 1 to 11. Got it.
yeah, so that's going to be 6 out of a total of how many numbers possible?
11.
11. 6 out of 11. That's right. All right. So that's pretty much how you do probability. Let's see if there's any other problems. Yeah, there are more. Whoa. All right, there are a lot of problems. So is it still the same? Wow. Okay, there's a lot of all right, well, let's see how far we can get. All right, this one says each individual letter each individual letter of the word Tennessee is placed on a piece of paper individually, and all 9 pieces of paper are placed in a hat. If one letter is selected at random from the hat, find the probability that that blank. All right, so sample space. Let's see. Sample space. The letter S is selected. How many letters are there?
9. Yeah, that's what it said.
9.
Yeah, you're right. 9. You're right. So the sample space is 9. All right. So how many? So that means that the denominator is 9 because there's 9.
Yeah,
Mhm.
2 out of 9.
2.
And then how many S's are there? Just 2, right?
2.
Yes.
Yeah, so 2 out of 9. All right, what about the letter S is not selected?
7 out of 9.
7.
Yeah, very good, because there are 7 that are not
Not S's.
S, yeah. All right, what about the probability of getting an S plus the probability of not getting an S? Well, it's just gonna be these two added, right?
Yeah.
So it's gonna be 2/9 plus 7/9, which is
9 out of 9, which is 1 whole.
1 whole, yeah. So 100, that means 100%. So there's 100% chance that you're either gonna get an S or you're not gonna get an S, which should make sense because if you pick a number, you're either gonna get an S or you're not gonna get an S. So that's 100%.
Exactly.
Yeah. So what's the probability that the letter is T or N? So how many T's or N's are there?
So it's either 2 out of 9 for the T, or for 1 out of 9 for the T and 2 out of 9 for the N.
N.
Yeah, so it's gonna be T is 1 out of 9
Yes.
and the N is 2 out of 9, right?
2 out of 9.
And so that's a total of 3 out of
3 out of
9
9, or 1/3.
or 1/3, yeah. All right, so that's the way it works. And then the letter W is selected.
0 out of 9. So
Yeah,
none.
so it's gonna be 0% chance. There's a 0 chance of selecting a W because there is no W's. All right, the letter V is not selected.
The same, 0 out of 9, so 0%.
9.
Almost, because look, it says not selected. So that means that it's not going to be selected. That means there's a 100% chance of happening, right? Because there's no V's.
Oh, okay.
So that means there's a 9 out of 9 chance of happening because it's going to happen for sure. You're not going to get a V because there is no V. So that means that it's 100% chance. That was kind of a tricky one. All right, let's look at this one. Example 4, the table shows the favorite soda of a sample of students. One of the students is selected at random. If one of the students is selected, find the probability that the student is female. So let's find the totals first. We can find the totals this direction. Let's find how many total males there are.
15.
15 females,
9.
9, and then Coke. That's 10. Sprite,
9. 5.
5. And then the total of everyone would
24.
be 24, yeah. So you can either add the column or the row. You should get the same answer, the same number, yeah.
Okay.
So what's the probability that the student is female? Well, the total number is the denominator. The total is 24. How many of those are female?
9.
9.
9. So it's going to be 9 out of 24. And we can simplify by 3, right?
Yes.
So that would be
3/8.
3/8, yeah. So that is your probability. All right, let's look at the card one. They put out all the cards. So it says one card is selected at random from a deck of cards. Determine the probability that the card is. All right, so here are the probabilities down below. So for the first one, it says a 2 is selected. How many 2s are there?
4 out of 52 is the answer.
Yeah, there's 4 and there are 52 total. So 4 out of 52. All right, what about a 2 or a 7? So for the 2, we said it was 4, right?
Yeah, could we simplify the 4 out of 52? It'd be 1/13.
Oh, you're right. Okay, so divide by 2. No, divide by 4, right?
I divided it by 4.
All right, divide by 4, and you should get 1 out of 13, right?
Yeah.
All right, thank you. Yes. All right, the next one is 2 or 7. So for 2, it's 4 out of 52. What about 7?
4 out of 52.
4 out of 52 again, which is a total of 8 out of 52.
Yes.
And we can divide by 4 again.
Yes.
That's going to be
2/13.
2/13. All right, what about not a 2? So you have to count all the cards that are not 2s. Well, we don't have-
48 out of 52,
Yeah, how did you get 48?
because I subtracted the 4 2s from 52.
Yeah, all you have to do is subtract the 4 2s from the total, which is 52. So 52 take away 4 is 48. So that means there's 48 cards that are not a 2. And we can divide by 4. So let's divide by 4 again. And this time we get
12/13.
12 out of 13. Yeah. All right, what about a red card? How many red cards are there?
26 out of 52.
It looks like half of them, right? Half of them are red.
Yes.
So it's going to be half of 52 is 26, right? 52. And if you divide, you should get a half.
Yep.
You do get a half because half of them are red, half of them are black. So that means that 1 out of 2 chance of getting a red card. All right, what about a club or a diamond? How many clubs are there?
13 clubs, 13 diamonds, which will give you 26 out of 52, which will give you a half.
There you go. Yes. So there are 13 clubs plus 13 diamonds. That's going to be a total of 26 out of 52, which we already know is a half.
I have.
So that means there's a 50-50 chance that you'll get a club or a diamond. All right. What about a card that's greater than 3 and less than 8?
So it'd only be the 4s, the 5s, and the 4s, the 5s, the 6s, and the 7s, correct?
Yeah, correct. Because it has to be between.
So then that'll be 12 that'll be 16 cards. So it'd be 16 minus 52 would be the number. So let me see.
Yeah, it looks like it's 4 times 4, right? 4 times 4, because you have 4 of these.
So
And,
38 out of 52.
wait, isn't it 16? 4 times 4?
Well, yeah, 16 out of 52, sorry.
Yeah, 16 out of 52. Yeah. All right, good. So 16 out of 52. Can we simplify by 4?
Yes, it'll be 4 out of 13. 4/13.
4/13. Yeah, that is correct. All right, good. So that is how you do that. All right, let's take a break and then we'll continue in a bit. So let's see. It's 11:42. Says use the data in the following table, which summarizes blood groups and RH types for 100 typical people. So we have a table. They give us a grand total is 100 people, and these are all the blood types. All right, if one person is randomly selected, find the probability of getting someone who is type RH negative. So anybody know how many people are RH negative total? Well, there it is.
14, yeah.
So it'd have to be 14 total. And how many total people are in this group? 100, right? That's the total number of people in the whole group. So our answer would be 14 out of 100. And we could simplify. Let's divide by 2. So if you divide by 2, you get 7 out of 50. Actually, either answer is correct. You could leave it as 14 over 100 if you want, or you can leave it as 750. So it's up to you. Unless the problem specifically says to simplify to lowest terms, then you would have to reduce. But if the problem doesn't say simplify to lowest terms, then you could leave your answer as 14 out of 100. All right. So let's continue. Part B. If one person is randomly selected, find the probability of getting someone who is group A. Anybody know how many total people there are in group A?
40.
Yeah, 40. So that would be 40 out of 100,
100.
which it can also be, if you divide by 10,
10
or actually you can divide by 20.
or 20.
You can get 2 out of 5. So either answer is correct. You don't have to simplify. Fundamentals of probability theory. Something that is impossible would have probability 0. A sure or a certain event, something that's certain to happen, is probability 1. That means 100. So this means 0%. This means 100%. For any event A, the probability of an event A must be greater than or equal to 0, and it has to be less than or equal to 1. So 100% means 1. So in other words, probability has to always be between. So probability of an event always has to be between 0 and 1. So that's what this means. Probability of any event will always be in between 0 and 1. All right, and then the sum of all simple events should equal 1. So let's take a look at an example that involves all that. Conditional probability. The most important step for conditional probability is to figure out the sample space. Okay. So it doesn't really give us anything here. We can just make up numbers, I guess. Let's see. Let's just skip this because there's no real questions. Let's go here. Let us use blood type chart to find the probabilities of the events listed in the chart below. The event is person is A plus given that they are type A. Okay. There's 35 A plus. All right, and there's a total of 40 possible outcomes. Let's see. So this, I guess you're not even supposed to look at the chart. This is just going to be 35 out of 40. Let's look at this. How did they get 40 though? Oh, I see. Out of 40 type A, see that are type A. So the total is now 40. And there are 35 that have plus. So 35 comes from here, from the plus, and then the total from group A is 40. So let's see, what's the probability that a person is A plus given that they are H plus? So this is the key, the given part, given that they are H plus. So how many H plus are there total?
86.
So 86 would be the total possible outcomes. And then from those, what's probably that you get an A plus person?
35.
35. Yeah, 35. So your answer would be 35 out of 86. All right, this time what is the given part? Given that they are Rh negative. So now we're only looking at the Rh negatives. How many total people are there?
14.
So that's 14 total outcomes. And of those 14, how many of them are O? 6, right? Because we're only looking at the Rh negatives. And of those Rh negatives, how many of those are O's? 6 of them.
6.
So 6 out of 14. And then the last one, the given part is Rh plus. So now we're just now we're only looking at the Rh plus people. That would be 86 total. And then from those, what's probably that they're O?
39.
39 out of 86, you're right. 39 out of 86. All right, so that's how you would fill out that table. Let's see what else we have. All right, so this one says results from tests for marijuana use. Did the subject actually use marijuana? So the test here is positive. They tested positive. That means they did use marijuana. Over here means they did not use marijuana, but they still tested positive. So it's a false positive. Over here, 3 of them did use marijuana, but they tested negative. So that's a false negative. Then 154 people that did not use marijuana tested negative. All right, so let's see. What's the probability that a randomly selected subject actually used marijuana given that the test result is positive? So there it is, the given part. given that the result is positive. So we're only looking at the positives. So we have to add those up to get the total. So let's get the totals. So the total would be 119 plus 24, which is
43. 143.
143. All right. And then for this one, it would be 157. All right, so we're only looking at the people that whose test is positive. So we're looking at a total of 143. That would be the total number of possible outcomes. And of those, how many of them actually used marijuana?
119.
119, because this means they did and this means they didn't. So 119 did. And so that's your probability, 119 divided by 143. All right, so let's look at this one. The event is, or let's see, find the probability that the person's result is positive. All right, so positive. Over here, the event was actually use marijuana. Actually used. All right, so the let's look at the positive. I'm sorry, let's look at the given. Given that he or she actually used marijuana. So that's the given part. That means we're looking at the yes, right?
Yeah.
So what's the total for the yes? That would be 122, right?
Right.
This would be 178. All right. So if we're only looking at the people that actually use marijuana, that would be 122. And of those, we want to find out how many of them tested positive. How many of these actually tested positive? One, yeah, 119. So that would be 119 out of 122. All right, so let's look at this next one. It says, let E be the event that a randomly selected person in the United States who is over the age of 24 has attended college. Let F be the event that a randomly selected US resident over the age of 24 is female. According to the US Census Bureau, the probability E is 0.47, and the probability of F is 0.52, and the probability of E and F is 0.27. All right, so let's see if we can fill out this box. So E is the probability that a person who is over 24 has attended college. So let's start with the both. E attended college and F female. So that would go here, no, yeah, here, right? E means attended college. F means female. That would be this one, 0.27. So we can just say 27. All right, out of 100. And then for this one, probability of a female, that would be 52. So that would have to be this total, 52. There's a total of 52 females. And if there's a total of 100 people, how many males are there? So we need to figure out how many males there are. You can just
It's
subtract.
100 subtracted by 50 or 52.
Yeah, subtract it. 100 minus 52, I believe, is 48, right?
Right.
All right, so now we have the total number of men. So now we can find this one because 27 plus something has to add up to 52. So you can just subtract 27 from 52. I think that's going to be what, 15? Oh, no. Is it 15? Or 25? 25. Yeah, it's 25. And then I think we're given one more thing. This one, the probability of someone attending college is 0.47. So that means this has to be 47 right here, because the probability of attending college is 0.47. So now we can find the number of males. So 27 plus what gives you 47? Have to be 20, right? So 27 plus 20 is 47. All right, now we can find this missing box. So 20 plus what gives you 48?
What's that? 48, take away 20.
Yeah, 48 take away 20, and that's 28. So if you add these up, you get 48. If you add these up, you get 52. If you add these up, you get 47. And if you add these up, you get 53.
53.
And these two add up to 100. All right, so you kind of have to work backwards. You have to start off with both. You have to start off with this one first. E means attended college, F means female, 27. So females that attended college would be 27. And we know that there's 100 total. We're just assuming so that the numbers work out. You always just put 100 there. And then everything else falls into place. So it says, what is the probability that a randomly selected person in the US is male? So how many total males are there?
48,
Out of
100.
100. Okay, so I'm just gonna write here 48. So 48 total 100. That's good enough. All right. You could put this the number of event if you wanted to fill this out. Number of event, number of possible outcomes, probability of event. All right, so now we can fill out this. What is the probability that a randomly selected person in the US has not attended college? Given, so here's that given that they are male. That means we're only looking at the males. So the total is
53.
50,
53.
48 total males.
Oh, okay. I'm looking at. Oh, okay. Okay.
Yeah, right. And then of those 48 males, how many of them did not attend college?
28.
28, yeah. So 28 of them did not attend college. So the probability is 28 out of 48. All right. All right. So that's what this means. This notation right here, see this bar? That's not an I, that's a bar. It's like they should have made it bigger. So it means given that. So this means what's the probability that the person is female given that they attended college? So the given that is that they attended college. So we're looking at this total attended college. So the total is 47. So that's the denominator. Then they say here, given that they have attended college. So we're only looking at the attended college group, which is 47 total. And now we need to find the probability that we select a female. So how many females are there in this group?
27.
27. So 27 out of 47 is the answer. So whenever you see the word given for this line, then that means you have to focus only on that group. So we're only focusing on people that went to college. That's your total, 47. And we want the probability that we select a female, 27 out of 47. All right, so that is that. Let's look at this next one. All right, so here's the example that the questions from that one example that we skipped. All right, so if you let's add up the totals again. So 119 plus 24 is 143. All right, and then 157 for this one. And then if you find these other totals, you'll get 122 and 178. All right, so find the probability that a randomly selected subject actually used marijuana, given that the test is positive. Oh wait, we did this already.
Yeah, I was looking, see, they look at the same thing.
Yeah, well, they just, yeah, we already did it. It's just duplicated. So yeah, don't worry about that. We are actually done. All right, cool. So we did finish it. Yeah, so this is hopefully it's not too hard. I don't know if you guys found it to be challenging or medium. But let's just look at the homework really quickly. Well, we don't really have time, but